Sorry?
Yeah, where was that? I know we signed up for it. Oh, did you sign us up to be guinea pigs for Pac-Man?
Well, the status of that was ambiguous. Colin had some objections.
Because that Pac-Man thing works so well.
Well.
I mean, I'm sitting in mine, I have no idea what the iconography is supposed to be. When you turn into the bad ghost, you know, the scared ghost, and then Pac-Man comes, did you step out of the queue, or this was redone, or? The Pac-Man comes and eats you down. Good to know. Can I actually control the Pac-Man if there's someone in the queue that I'm not sure should be there? Well, but I understand from the plenary last night that hacksaws might be able to take over these kinds of devices. There is a thing. It's on the internet.
On the internet, yeah.
But we really had 4 bottles of wine in there last night. Yes, I have. The transport started, the alcoholism, and what do you think about it? Spirits, pint, I mean, all those were transport crews, right?
All right.
All right.
Like 3 past.
Shall I cheat?
Yeah, well, there's a slide. I'll go ahead. All right, we're about 9:02 here, so we're going to get started. I've got the blue sheets. You know what to do with these. If you don't, ask the person next to you. Oh, yeah. Sorry.
Yeah, where are the Meet Echo guys?
Someone's supposed to be driving that.
We do see there is a cockpit for Meet Echo, but it is unoccupied.
So he can't hear us at all?
Okay, so we have some audio. That's good.
Okay, we'll do it old style.
Okay.
Jabber room.
Meet Echo will hopefully join us, but please note well what you see on the screen here, in case you have never noted this well before. The blue sheets are currently circulating. We have note takers picked out for this, or so we need
2.
We need 2 volunteers from the audience who are going to record for posterity the momentous events that are going to transpire here today. This is actually an important role. Think of yourself as writing the first draft of history. Oh, I see one. Cullen Jennings, I trust your control of all matters historical. Yes, I have.
That's why we want 2.
Yes. We need a backup. Let's be frank here. We need someone else. No, seriously, please, someone else. Oh, thank you.
Excellent, thank you.
And scribing to the jabber, is anybody going to be recording, especially without Meet Echo here? I mean, I think we really need somebody who can tell people in the jabber room what's going on.
Well, more important, okay, actually. This is pretty important. We have known remote participants right now, and I suspect they're going to want to say things from time to time. We want someone who can take those comments to the microphone. That's the #1 job. Excellent. Thank you, Joe.
Perfect. So this is what we're thinking we should do today. If you think we should do something other than what is recorded on the sheet, this would be an excellent time to stand up, go to a microphone, and talk about it. Barring that, I think we're going to advance. Our esteemed area director, Richard Barnes, will now be regaling us with his important perspective on why we're here and what we're trying to accomplish. Richard.
So if there's any lesson to take away from today, it is not to go out to dinner the night before a meeting such as this with these fine fellows to my left. So I just wanted to provide folks some context, remind folks of the context of how we got to where we are today and what we're trying to accomplish here today. So all the way back in IETF 75, there was a codec BOF in Stockholm where we were trying to address the question of whether we could make an audio codec that would be reasonably would have IPR terms that the community was comfortable with and could be used widely across the internet for a variety of internet applications. And we formed a working group out of that developed the Opus codec, which is now something that WebRTC is making use of and is getting pretty broad use across the internet. So the sort of founding myth of the video codec effort is the success in the audio space. That we feel that's one of the successes the IETF has had in the last few years. So I believe it was 10 IETFs after the codec BOF at IETF 85. We had a video codec BOF, which was the first meeting where we actually got together in IETF meeting and said, okay, maybe we can do this for video. There was some really good initial energy there. That fed into some mailing list discussions over the intervening time, trying to refine that concept, get to more precise charter text about what we're trying to accomplish here. There was a meeting just 2 IETFs ago at Toronto where we got sort of a more firmly coalesced community. And that brings us to today, where we're trying to make sort of a final decision about what we're going to do in the video codec space and what the goals of a video codec working group might be. So with that, I think I'll pass it back to the chairs to take it away.
Thank you, Richard. Adam, why don't you drive here?
Right. So this is kind of reiterating most of what Richard said at the end there, but what we're trying to accomplish here is coming up with a video codec that is specifically, we're doing something that's going to be optimized for real-time communications. If we end up with something that's good for like disk storage, great, but that's not really the goal. We want it to be at least as good as state-of-the-art, if not better. And we do want it to be viewed broadly within the industry as having IPR licensing terms that allow for wide implementation and deployment by both major commercial entities and open source projects, basically the entire gamut of interested parties. And importantly, as a means to achieve this, we want to make sure that it's developed under the IPR rules that are established for the IETF in these 2 documents, or I guess it's 3. If you want to go read through those, it probably throws that a bit into relief. And again, repeating what Richard said, we think we can replicate the success that we had with the audio codec BOF. I see Keith is coming to comment.
So Keith Drage. So can you clarify where we are in the approval phase of this working group? Because I've just seen the AD stand up and say pretty much this is a done deal, and you just seem to have repeated that. So is this basically, this is what we're going to do, thank you for coming to the meeting, or is this actually, we are deciding whether we want to do this, or somewhere in between?
It's a proposal, which is why the slide says proposed. I'll let Richard speak to his words.
This is Richard Barnes. So Keith, I'm sorry if I was unclear. I didn't mean to propose that this was a done deal. I said that our goal here is to decide whether we will do something in this space, and if so, what that will be.
Okay. Progress so far. The need for this kind of work, even though it was sort of floating around as a concept before this, really was quite apparent during the discussions in WebRTC when we were trying to determine which codec should be mandatory to implement. And there wasn't something that really fit the bill to everyone's satisfaction. We ended up with a compromise that no one is happy with. And so that, I think, puts a fine point on why we want to do this sort of thing. Not to make an MTI for WebRTC, let me be clear. That's not what we're deciding here. We want to come up with a codec so that the next time we find ourselves in that kind of situation, the answer will be clearer. And work on DALA and BP10, which are kind of operating sort of in this space, has been making good progress. There have been a lot of conversations on, did that just go, what happened? Sorry. There's been a lot of conversation on the video codec list ever since IETF 90, when there was sort of an informal barb-off style discussion of how to make this work move forward. And then there are a lot of individual drafts that are out there that sort of could form a foundation for the work of a working group if it gets formed. And there are already even a couple of RF license grants on file if you want to go read through both of these. They're both from Mozilla based on the dollar work. Okay, and now I'm going to hand it over to Mo.
Okay, so we're going to talk about some considerations for this work, and you'll see what this loose word considerations means. Next slide, please.
Yeah.
Is it coming across in the room?
It's good. But I think if there is a video stream that's working, they're going to want you to stay in the box here.
The
For
box.
what that's worth.
Okay. Stay in the box. So the primary consideration whenever you're doing codec work is always compression efficiency, but that's not the focus of this talk. We really want to look at what may be necessary beyond compression. And let me just jump straight to the bottom point, because I think that's really what's important here, is we need to figure out what are the important considerations for this work, and how strong should they be, where should they be recorded. Are there any things that need to be charter level considerations? And then if not charter level, should they be in requirements? And if not requirements, then should we have them part of the evaluation or testing specification? And this is assuming we're going to have a later discussion about, what the milestones would be. But we're assuming here there's going to be some sort of requirements and evaluation document. Back up, so yeah. And so beyond compression, we have some of these other aspects that we need to decide on. And just to quickly run through them, complexity, which I think there was some recent discussion on the mailing list about. Parallelism, which is somewhat tied with complexity as well. Elasticity and rate control, those are two also closely related aspects. Error resilience, scalability, and then content-specific tools, so identifying the differences between camera and synthetic content, maybe some tool differences that may be relevant for that. And then finally, probably the hardest one, algorithmic agility, to see if there's anything we can do to avoid IPR that becomes known. Okay, next slide, please. So starting with complexity, the fuzzy word here, reasonable, is the difficult thing to have any kind of true specification of. But we want the codec to be able to have memory and computational requirements that work in software implementations across all modern systems. We shouldn't need to rely on specific types of accelerators like many new codecs typically do. So computational complexity may be more of an important aspect in this work than in maybe some of the other standards bodies, because we do expect software implementations to be the primary focus for initial deployments. And this may be something that may need to iterate fast, and so software implementations may be the most important implementations even going forward. And of course, if it's successful, it should be burned into hardware for even better efficiency. And so hardware presents some unique design challenges, and we should make sure that any of the algorithmic components are not something that's inherently bad for hardware implementers. So the evaluation methodology, assuming we have such a draft, should definitely take complexity into account. Exactly how, though, is going to be a challenge, and we need to avoid some of the common pitfalls of trying to have precision about the complexity, because in the research stages in developing codecs, you don't want to focus on things like optimization. Those things are typically counterproductive in the research stages because it makes it more difficult to iterate and more difficult to experiment. So there's going to have to be a pretty broad understanding of what the complexity and compression trade-offs are. And this is true for any codec. It's not unique for this work. Every codec design always has this balancing act of compression efficiency versus complexity. And so we need to make sure that the evaluation methodology captures that in some sense, but not too finely to restrict experimentation. Next slide, please. So to help with complexity, we naturally turn to parallel implementations because modern hardware is very parallel. And there's two broad levels of parallelism that we need to take into account. At the very high level, you have many cores. So you want broad strokes of parallelism where the algorithm can operate on multiple frames or multiple subframe regions in parallel. So you can use up all of your cores. And there's a particularly important part when it comes to the entropy encoding of the streams. So for those that haven't dealt too much with video codecs, entropy coding is like zipping the final representation of it, the lossless coding part of it. But that step is key to make highly parallel because we want to be able to spread different parts of the stream across different processors. And we want to be able to make sure that there's no dependence between those parts of the stream that we want to push off to different cores. And the traditional approaches taken with that have been 1D slices. More recently in recent work, there's 2D tiles, and other codecs have similar concepts like partition maps. So we're going to need, I think, something like that in this work. And then there's a lower level of parallelism at the instruction set level. So to make the algorithms match well with instruction sets of modern CPUs and GPUs. So leveraging SIMD wherever possible, leveraging GPU compute wherever possible. That should be a goal. And so algorithms that favor that kind of design should naturally be chosen for this work and avoid kind of serialized algorithms. Next slide, please. Okay, so elasticity and rate control. This is maybe one of the unique things about the work here. In most other codec development, the primary application is typically stored formats and streaming formats. And so the work is focused very deeply on optimizing for those use cases. And when it comes to internet delivery of that, you see an overlay on top of that codec design to allow internet delivery. So we see things like MPEG-dash systems and just re-encode the stream in 4 or 5 different bit rates and grab the chunk that fits the best network bandwidth at the current time. So the focus historically has been on keep the codec very well optimized for squeezing the heck out of the content, entertainment content mostly, and when it comes to transport, let's do an overlay to make it work okay over transport. Whereas in this work, I think we may have a unique focus in IETF to make sure that it works best on the internet from day one, and rate control and scalability and things like that are more ingrained into the codec design than traditionally. And so for the very basic rate controls in current encoders, you have the ability to adapt the quantization or skip coding frames or subframe regions entirely. Those are the two primary knobs to go up or down in your bit rates. And so we're definitely going to have at least those two knobs. Adapting resolution is typically done when you have a more drastic change in bandwidth that you need to accommodate. And traditionally, codecs have done that inefficiently. Good news with VP9 is that it does it more efficiently. It has the scaling of reference frames to allow very efficient resolution change. So I think we should have something like that in this work as well. And when you look at the granularity of adapting these rates. The sizes of codec blocks, or codec algorithms typically operate on these blocks, and the sizes of those blocks tend to be getting larger. Today we're like at around 64 by 64 for a lot of modern codecs. And as you start getting larger and larger, the amount of granularity you have in your rate control sometimes becomes less. And I think we're pretty close to the point where we want the minimum granularity that may be needed is a row of the fundamental block size. We're already at that limit. We may need to make sure that we can adapt the quantization or the output bits, the number of bits that you're outputting for each block. That may already need to be at least a block row basis. So that's, I think, an important consideration for this work. Next slide, please. Air resilience is also closely tied with making sure that this work is focused on internet delivery. Whenever you have packet loss, it's unavoidable in any codec to have some kind of artifact. And we're ignoring transport level things like retransmission or FEC. When you have post-repair packet loss, it's unavoidable to have some sort of distortion. But some of the key things are we have to make sure that we specify decoder operation that is robust against those losses. We can't be out of sync in terms of parsing the stream. So you can't have entropy encoding that's dependent on some prior frames or some prior subframe regions. We need to make sure that entropy encoding at least is very robust to this. And the flip side of that is the distortion keeps spreading until you fully resynchronize the encoder and decoder. So we have to make sure that resynchronization can be efficient. So today, in the most basic systems, you just do a full intra refresh, and that wipes away all the problems. But that's a huge number of bits on the network. It's a burst of at least 2, 4, or even 10x what your typical bit rates are for the non-intra frames. So we need to make sure that we have some sort of efficient resynchronization in the design, and that's accomplished today with things like adaptive intra refreshes with long-term reference frames, also called golden or locked in other codecs. Next slide, please. And then scalability. So scalability is something that is sort of there, but not always obvious in some codecs, especially temporal scalability. For example, in H.264, it's always been there, but hasn't been acknowledged until a later annex for SVC. But we need to make sure that we address temporal scalability at the very beginning and have the right higher level syntax for it. So the benefits of temporal scalability are you can use it to help with that congestion control aspect. When you want to have very fast rate control, it's pretty easy with temporal scalability to have a pretty big impact on your rate. You can easily drop your rate by half or even more depending on how many layers you have. So it's a very effective knob for fast rate control. It's also able to give you some kind of rate diversity, continuous, constant rate diversity to multiple receivers. Now that works within certain bounds. It doesn't work for a 10x difference in rates between receivers, but it may work for a 2x rate difference. And finally, and probably most importantly, it's actually pretty efficient. It leads to often better compression efficiency than not using it. And it's not really inherent in temporal scalability itself, but it's inherent in the ability to quantize some of the frames more strongly. And by doing that, human perception doesn't really get affected by the lower bits in every other frame. So you typically end up with better bit rates when you apply temporal scalability. There's also resolution or quality scalability in other codecs, and it's a little bit more of a mixed bag there. whenever you do that, you typically degrade your compression performance. And this is compared to a single flat stream. So they come at a cost. Now, for a lot of applications, paying that penalty is okay. Paying the extra cost of having resolution scalability is acceptable. A typical example would be something like, a 720p plus 1080p stream. That is an effective use of spatial scalability. But if you're going to do a 180p stream and a 1080p stream, then spatial scalability is not really buying you much there, and the penalty is not worth it. You might as well just simulcast those two resolutions. So whether or not those dimensions of scalability are important in this work is probably less clear, but it may be enough just to support rescaling whatever is in the reference memory of the encoder. So being able to normatively rescale any reference frame is probably enough to achieve a decent level of spatial scalability. Next slide, please. And then content-specific tools, we want to look at it in two ways. Number one is we need to make sure that for evaluations, we want to make sure that we have all the content classes that we care about represented. And so there's been some discussion on the list about how the content should be broken up and classed, how many different streams and of what type should we have. But I think it's been reasonably clear that we should have some camera content and some synthetic content, non-camera content, anime or screen shares. And that'll be important for a lot of forward applications like wireless display and remote gaming. So when you have that type of synthetic content, it typically requires tools that are not in the base codec standard. For example, RGB 444 coding. A lot of codecs will skip all of those tools in their first version, then try to tack them on later. And I think we should, at the beginning of this work, make sure that we're clear about what application spaces we're going after and what are the right coding tools for those application spaces. And it may require things like different search strategies, broader search ranges, different coding tools, maybe even more components, not just 3 color components, but alpha and depth, and ways to exploit all the redundancies between all of those planes. Next slide, please. Okay, so the final point, and probably the hardest point, and probably the most unique in other codec work, is this goal to have an RF codec with very clear IPR. And that may require some agility because there's so much IPR out there. It's very unlikely that we're going to be able to skirt all of it with the first stroke. So we need to figure out what would be the process for avoiding anything that we think is an unacceptable IPR risk. And how we do that technically is going to be a challenge. Process-wise will also be a challenge. But if there's anything that can be done technically inside of the codec design itself to allow algorithmic agility like that, that's very hard to think about how that could work, but it's something I think we're going to have to really think about hard. That's it. Thank you. Questions?
Good morning, Frank Barson. Just some things you haven't touched upon are resolution and bit depth. What do you have to say about this in this context?
Yeah, it's a good point. We did have a little bit of discussion, I think, on the list about that. In the very rough requirements draft that exists, it does mention resolution and bit depths, and I think even also color gamut and things like that. Again, I think it's more along the lines of the determining what applications are most relevant for this work. If people see a strong need for professional applications, then we need to seriously consider deeper bit depths, and we may need to look at wider color gamuts and things like that.
Keith Drage. So every time you invent a new codec, you introduce, for me and my customers, a transcoding problem, because basically you don't solve the problem of saying, right, everybody else in the world, remove your existing codecs and use this one. So basically you end up with multi-point conference units or whatever that have to effectively do transcoding. I think it has to be in your requirements that you don't make transcoding more difficult. I mean, yes, you can throw resources and money at doing the transcoding, but if you actually fundamentally design it so it's impossible to reduce the transcoding delays, then you have a problem. Sorry?
You make transcoding more difficult. He was wanting to plumb that.
Well, what I'm saying is you can throw the resources and the processing power at it, but if you actually make it so that transcoding delays are impossible to reduce, then you have a problem.
Can you clarify, Keith? Do you mean transcoding between this new work and existing formats, or transcoding between different versions of this new work?
No, between this work and existing codecs,
Okay.
of which we know there are many.
Okay. So that maybe that's almost an argument to try to stay like existing codecs in their architecture, which is.
Well, I don't want to place that constraint on you. What I want you to make sure is that we can actually, address the delay problem in transcoding, and it isn't made impossible because of the way you've defined the codec.
All right. That's a fair point.
So, Tim Terrybear from Mozilla. I agree that that's probably an important consideration. And I also wanted to echo the question about bit depth, since that's certainly, I think, relevant to many people. The other thing I wanted to touch on was the spatial scalability. So on your slide up there, you say that perhaps just having scaling of reference frames is enough to get that to get what we want here. As you know, the IPR situation around spatial scalability is quite nasty. So do you think there's any reason to try to explore doing more than that, or do you think that's even feasible?
I'm just asking the question. It takes an IPR expert to review all of those spatial scalability claims and see if there's a potential design that can avoid some of them.
Bernard about Microsoft. I'd first like to answer that point. I do agree with what you said, Mo, that spatial scalability probably isn't a requirement, because in particularly in a lot of the WebRTC scenarios you see with like a thumbnail or something, it's actually less efficient than the simulcast. But I wanted to make two other comments. I think since the Opus analogy has been mentioned, it's worth thinking about what made Opus successful. It wasn't just the IPR thing, right? There were some unique propositions that it had, one of which was the dynamic range, which was outstanding compared to what came before. And the other one was the ease of configuration, which does, and a lot of the stuff being in band, which is helpful. So, I saw most of this concentrated on the bitstream aspects, and there were some good ideas in there, and I'll have a little bit more to say on that. But you might want to also think about some of the higher level stuff you want to achieve. Like, do you want in-band FEC, for example, is that part of it, which might make the negotiation a lot easier? Are there other, unique selling points? With respect to the bitstream, I think there are some ideas in there that might be particularly useful in lowering the iframe hit. And it's worth understanding that it's not just a hit in steady state, but when you do switches, right, you often end up sending FIR messages and then you get this huge iframe. And so maybe the resolution scaling could help with a little bit of that, in particular if you didn't have to send an FIR and if you could send P frames off of the rescaled thing. That might be a significant selling point given how many FIRs tend to be flying around. So something to think about.
Jean-Marc Bellin. About the ease of use of the codec in RTP and those sort of applications and how to set up configuration. I believe we have either in the charter or in some draft some statement that says that we're going to actually look at the RTP payload format at the same time as the codec itself, and that is what made a big difference in the case of Opus. Like, we had RTP directly in mind when designing the codec itself, and we need to repeat this here.
Yeah, that's a good point. We should probably make sure that that's highlighted in one of the. Is that already a charter level item, or is that a requirements thing?
In the charter level draft.
Okay. Yeah.
Great, thanks. So now we're going to have Tim come up and talk to us.
All right, can everyone hear? So probably should just hold it. So I'm going to talk a little bit.
You have to be real close to it.
Yeah, I'm going to talk a little bit about the DALA project, which is one of the potential technical contributions for this effort, and some of the progress we've made so far. So next slide. So this project had two main goals, one of which is to be better than state-of-the-art compression, and the other one is to have a defensible IPR strategy. So next slide. So the way we decided to go about this is we want to replace major codec building blocks with fundamentally different technology. So this is sort of in contrast to some other approaches that have tried to do incremental evolution. Like we want to replace whole chunks. And this is, a much higher risk approach than the incremental evolution approach, but it also has potentially higher rewards. We might be able to escape some of the local minimums that current codec development has worked into. This has advantages both, for that potential higher reward to get better than current technology, but also on the IPR front. By being sufficiently different from the way current codec designs work, we have the potential to avoid large swaths of patents, even ones that we are not perhaps aware of. And even the ones that you are aware of, the actual boundary of where exactly what exactly you can do that doesn't violate the patent is only ever decided by 12 members of a jury, and you usually don't want to get to that point. It also means that lawyers reviewing these patents don't have to make perfect decisions, right? If we can just say something very, very clear, this clearly can't apply because we're doing something totally different, that's much better than, well, it doesn't apply because of this tiny little technical detail, right? It also has the side effect that it creates new challenges that other people have simply never had to solve before. Which gives us, moves us into an area that is generally much less patented. So next slide. So to start off with, we identified 4 key areas that we think we can avoid completely. One of those is quantizing the residual of a displaced frame difference. So a displaced frame difference is the result of doing motion compensation and subtracting it from the thing you want to code. And so we have a way of coding things that does not do that. We wanted to avoid adaptive loop filters, and so we do something else instead. We wanted to avoid spatial prediction or intra-prediction, and binary arithmetic coding, in particular the context modeling of that, which tends to have a large number of patents. So next slide. So now I'll go through each of the new techniques that we have come up to replace some of those 4 key areas. So to start off with, we have perceptual vector quantization. And so this is a way of coding coefficients. And the idea is that instead of doing traditional scalar quantization where you do a transform, you get a bunch of coefficients out, and they're just a set of numbers, and each one doesn't have any particular meaning. We try to reduce this into a few parameters that have very specific meanings, and then a set of data that covers the rest of the space, right? So one of those parameters would be the energy of the signal. And so we actually, we have some vector that lives on some sphere, and we actually code the radius of the sphere, right? So we have an explicit energy parameter in there. We also have, so we still want to be able to do this with prediction, so we compute what's called a householder reflection here. You can go to the next slide, which maps the prediction onto one of these axes, and then we can measure the angle between the input and this axis, and that parameter tells us how good is our prediction doing, right? It's another very intuitive parameter. And at the end here, we have this n-1 dimensional sphere of possible vectors that are left, and then we can just code that using traditional vector quantization, much like we did in Opus. And so the key point here is that we're never actually subtracting this prediction from the input. Instead, we're always coding the original input vector, with this scaling and reflection operation in here. But we're using the prediction to modify the probabilities of the vectors that we're encoding, right? So it's a very different way of thinking about it. And it also lets us do some other interesting things, like because we have this explicit energy parameter in there, we can do things like activity masking, where you want to code regions that are flat with or generally low activity with higher quality than you might regions that are very active, just because people notice small changes when there's not much going on, as opposed to when there's lots of details. And this energy parameter turns out to be exactly the piece of information you need to know to do that. And so other codecs will generally have to code side information to specify, where to spend more bits or fewer bits, but we get that for free in our encoding because we have these meaningful parameters. And as I said, it codes these blocks with a predictor without doing subtraction and coding a residual. So any patent that has that as one of its steps, we avoid completely. And if you read patents, you'll find a lot of them have that as one of their steps. So next slide. I said we wanted to avoid adaptive loop filters. And so instead we are using lap transforms, which you can kind of think of as a non-adaptive deblocking filter. One of the other key features is that it is invertible, which means that the filter we apply on the decoder side, we can exactly invert on the encoder side, and that's why we don't have to be adaptive. All right, so the way it basically works is you have your traditional block transform, and in between the blocks, you run this post filter on the output, and then on the encoder side, you can run the inverse of that. All right, so next slide. I said we wanted to avoid doing intra-prediction, in particular spatial prediction. And so part of the reason is that because we have these lap transforms, we can't do traditional spatial intra-prediction, at least not in the same way that people normally do it. So you can't copy, so the way spatial prediction normally works is you copy pixels from your neighboring blocks. And we can't copy those pixels until we've undone this lapping, until we've run that post filter. But we can't run the post filter until we have the pixel data to feed into it. So instead of copying pixels, we now copy transform coefficients. So currently we just have two modes, a horizontal and a vertical mode for Luma, that copy the first row and the first column. And then on Chroma, we predict our Chroma coefficients from our Luma coefficients. So this is not as good as spatial interprediction in terms of improving coding efficiency, but we make up for that in different places. So, for example, the lapping itself will improve coding efficiency in ways that are very similar to intra. We spent a lot of time trying to think if we could do something much more complex than this that would actually get performance as good as traditional intra. And if your complexity is no budget at all, I think you can probably do it. But with a reasonable complexity, we found it was better to go with something that was much simpler, but still was useful in specific cases. So for example, we can construct specific clips like a giant checkerboard pattern or something, where this gives 50% bitrate gains, right? But on normal content, it's probably more in the 1% to 2% range, which is a bit less than normal intra. But on the other hand, it's much cheaper than doing traditional spatial intra prediction. Right? We don't have to copy as much, and we can pipeline this much better with the decoding stage, because we don't have to decode all the way to pixel values in order to predict the next blocks we want to predict. Right? So for hardware implementations, this actually works out better. So next slide. And I said we wanted to avoid binary arithmetic coding, and in order to do that, we actually go all the way back to the more traditional multi-symbol arithmetic coding. So we code up to 16 possible values per symbol, which is equivalent to doing 4 binary decisions at once. And so it turns out most of the processing overheads of arithmetic encoding are actually per symbol that you encode, right? So by reducing the number of symbols, we get better throughput per cycle. That goes back to the things Bo was talking about entropy coding is usually an inherently serial process, and by reducing the bottleneck there, we can reduce clock rates that things have to run at in order to decode a frame. So it also avoids binary context modeling, since we generally don't use binary contexts because we want to get as many different symbols as possible or as many different values as possible in each symbol we encode. So we use things instead like the traditional frequency counts, which is basically the way early arithmetic coders were designed. We can do this without doing divisions, so we have some techniques for that. We also, when we know particular data follows an explicit statistical model, then we can have a model of, for example, a Laplace distribution or an exponential distribution, which is parameterized by a single value, so like say the expected value or the mean, right? So the context becomes very easy to update, and we can keep much less state in order to do that. We also currently in our development have what we call the generic encoder, which is a fairly complex design, but it allows you to kind of use it anywhere and get something that gives you reasonably good results. And we'll expect to be replacing that with more specific models as we get closer to the final stages of this codec. All right, next slide. So one of the advantages of not having to compete with others in order to get specific IPR in is that we don't have to come up with really direct objective metrics of, what should go into the codec, right? And specifically, we are not trying to tune for PSNR, which seems to be the only thing that anyone can ever agree on as an objective metric, even though we all know that there's lots of ways in which PSNR is bad, right? So many of our changes actively hurt PSNR, and to give you some examples of why PSNR does not work, next slide. So this is an image coded with one of the current MTI codecs for RTC Web. So the PSNR up there is 33 dB. And next slide. And that did not come out great on this projector.
Yeah.
But in particular, look at So this is an image coded with Dala. Can you flip back and forth a few times?
Sure.
Yeah. So if you could see it on the slides, if you download the slides on the if you download the slides from the web, like in the MTI codec example, the addresses are all basically flat, and in the Dala example, they actually have folds and things in them. So you can see that a little bit there, but
we can see it up here.
Yeah, it's good on this screen. If you want to come up afterwards, you can.
Take my word for it.
But the PSNR is over 2 dB worse, right? But the image actually looks better. And so that's one of the reasons that we are actively not tuning for PSNR. So we've been looking at several other metrics instead, and there's been some discussion of those on the list. Next slide. So this is one of them, particular fast multi-scale SSIM. And so this sort of gives you a map of how Dala progress has been going over since the beginning of last year. And so you can see we've reduced rate overall in that time by 70%, and we're moving at a pretty good clip. And so we are already passing H.265 at fairly high rates. So around there is what we consider high-quality YouTube, and around there is low-quality video conferencing. And somewhere up here, we're doing better than 265, and we expect to get that bottom portion of the curve to continue to move up as we proceed development. All right, next slide. So this has been the work of 37 different contributors. And if you got an early version of the slides, we actually had Nathan up there twice because he committed with 2 different email addresses. So thank you to all of those people. Next slide. And to be very clear, like this is not a finished product. This is just a contribution of a place we could start, right? So these results have no B-frames or alternative reference frames. We don't actually even consider using intra in the middle of our motion search. Our motion compensation blocks cap out at 16 by 16, which, as you just heard Mo say, most other codecs are up at 64 by 64 now. Our largest transform is only 32 by 32. We don't have a deringing filter, though we have one that is designed, it just hasn't landed yet. So there are a bunch of clear ways that we can improve the results that we've shown here. Next slide. So the overall summary is that we think we're making good progress, and we would like to contribute this as a potential candidate for NetVC. So are there any questions?
Frank Boston. Could you go back to the slide where you have the results?
Yes.
Can you say a bit more about this? What do you call H.265? What sequences did you use?
Right. So these are run on a small set of about 6 different sequences. We have a larger set of 19 that are largely drawn from the HEVC site, but we don't have the data for all the different runs on those. So this was, I think, Parkjoy and I'm trying to remember what the other ones in there are. So some of the lower resolution ones like Accio and yes, Syntel, so we have some synthetic content in there as well. And this is run using X265 at I think the very slow preset, which was about as slow as we could tolerate.
Okay. Do you know how this X265 compares to other H.265 encoders?
So I believe it is probably somewhere on the order of 10 to 20% worse than the reference model on PSNR. On FastSSIM, I don't know which one would actually do better.
Okay. And what type of encoding did you do? Do you only have one iframe at the very beginning? Do you have regular iframes?
Yes.
Is
So
it
all of these
low latency? Is it
so all of
high
these
latency?
sequences are 1 second long, and we've not configured the either encoder to run in a low latency mode. I mean, we don't really have anything but a low latency mode, but X265 has full ability to use B frames and reorder things and all of that.
And it has been doing that here.
Yes.
And well, then about the metric. I mean, we've had discussion in the past on this metric, so we know it has some shortcomings.
Yes.
Because basically what it does is downscales the image first and then computes something.
Yeah. So I mean, yeah. So if you try to mechanically tune for the metric, like you can do dumb things, right? We have not tried to do that. We certainly make decisions, based on how they affect the metric, but we haven't tried to, like numerically optimize quantization matrices for it, for example.
Yeah. Now I'm pretty sure you also have results using other metrics.
So we do. They generally don't look quite as good as this. So probably this and PSNR HVS are the two that we care about the most. And so PSNR HVS tends to do a good job of representing like how well you preserve clean edges and things along those lines, right? As opposed to multi-scale FastSSIM, which tends to focus on how well you have, how well you preserve texture and details and things like that. And so we are probably not doing as good a job there as 265 is at the moment. So one of the reasons is our simpler interprediction. The other one is that we don't have this de-ringing filter landed yet, so that we expect will improve things. The interesting thing is in our early tests with that is it gave a very strong visual improvement, but actually didn't move metrics that much. So I'm not even sure what that means, but.
Okay.
Yeah.
But essentially we should take these results with a grain of salt.
Absolutely.
Yes.
If you would like an entire salt shaker of salt, I can.
One other thing is you were talking about your lying eyes earlier. You tried to show some still images.
Yes.
Do you have any actual video to show? And the other question is, how often do you actually look at video when you do this work?
Right. So I don't have any video prepared to show at this presentation. We do try to look at video fairly often, and so we have we have tools set up that you can actually step through videos and go through things in detail. We have some scripts set up so that it'll play like 1 second clips of one followed by the other, so you can compare two sequences and actually like see the motion and things like that. So we do try to pay attention to the actual visual quality of changes instead of just looking at curves.
Yes, because one thing any of these metrics won't capture is temporal artifacts.
Right, and if you know of a good metric that will do anything in that regard, like I haven't seen anything that I would trust or even vaguely
If I knew one, I probably wouldn't be here.
Right.
Mosinati. So I think Frank's comments really underscore probably the most important aspect of the external view of this work, and that's the evaluation results and even the methodology itself. So I think that would have to be a very critical milestone and focus area for this work, because everyone else outside of the contributors of this work, that's almost all that they're going to look at. And we need to make sure that we understand all of the different dimensions that are important to capture. It's ironic that people compare video codecs with non-video metrics, but if we can come up with something that actually captures video quality instead of still quality, that would be interesting. And I think the other point on complexity is important to have very clearly spelled out in the evaluation criteria too, because you mentioned that you're testing against X265, and then Frank asked, well, what about HM? And one of the things I think we have to make sure is clear is that the goal of this work is going to have to be the real-time implementation performance. So we can have metrics for the offline performance as well, but I think we're going to have to really focus on what is the true real-time performance. And if you look at real-time software implementations or hardware implementations of these codecs, they usually fall, at least. I don't think it's just 10 or 15%. I mean, in my experience, it's usually half, if not worse, than reference software. So I think we need to make sure that we're very explicit in the evaluation methodology about those operating points, and that we're focusing on the right areas for real deployments.
Right. So we had some discussion about this on the list, and like, I think having different modes you can run the encoder in is probably one way to achieve that. It is more work to do, right? So, we said in other standards bodies they tend to optimize for the hours per frame, level of complexity, and say, we'll speed that up later, right? As Harold was saying, and so having some real-time modes, or at the very least much simpler modes, that we think could be optimized to real time if we spent more time on it. May give us some level of estimate of what that actual drop-off is, right? I'm not sure of a better way to go about that. If you have ideas, please let me know.
So I beg you, do not show any video on this screen. I cannot even read your slide.
Yeah.
Do we know what the problem is here, by the way? I mean, these aren't like coding artifacts.
So I think this projector is actually running at 640 by 480.
Oh, okay. Perhaps we can fix that. It's actually really nice to be able to read this graph. I know it's not your fault, obviously. So serious question. Those vertical lines that you have tagged for low quality video conference and high quality YouTube, can you give me some kind of sense of what those are in terms of bits per second for, say, 1080p?
Right. So for 1080p, HQ YouTube is probably around 6 megabits a second, and the low-quality video conference, I don't remember the number, is probably either 1 megabit or half a megabit.
Okay. And I guess the other thing I was going to mention that Mo was saying is, people were at the hackathon on Sunday, I guess, there's been sort of a lot of. One of the things that's happened is, as open source has become more popular, is people have learned how to do these collaborative efforts and to have continuous, monitoring of how well things are going. And I know you have a platform for continuous monitoring of how well Dala is performing. Can you talk about that a little bit?
Sure. So we have a website we call Are We Compressed Yet? The traditional Mozilla fashion of Are We X Yet? For various values of X. And we let people, so we basically scrape a bunch of Git repositories, and we let anyone who wants to can add their Git repository to the list, and then they can push changes there, and we'll run them on sets of video and collect data for them. So that's been a relatively recent development over the past year, so it's why we don't have data all the way back to January from that system. We've also got a timeline on there, where we can measure progress at some specific bit rates. I think currently only 0.1 bits per second, which is again around the high quality YouTube level. 0.1 bits per pixel. And yes, so you can monitor progress there and see how we've been doing. So I'm not sure if you have that's enough for you, or you have any other more detail you want to know about it.
My question is, would this be usable for technology, for any codec effort, regardless of whether it was, if it worked in a different way than Dala, would this still be usable for other?
Yeah, I mean, like as long as you write a script that can build in on the codec, right? So I mean, so we also use the same platform to measure X265 and 264 and VP8, VP9, and get results for them, so we can do our comparisons, at least on the metrics curves.
Greg Maxwell. So earlier Mo mentioned sort of the pain and danger of premature optimization, and there's been some comment about the comparison point, what's H265 here. The HM reference implementation for H265 is like hours per frame if all of the bells and whistles are turned on, and that plays into some of the questions about how often do you actually look at it. So I thought you might like to speak some about what your views are about how fast the research work needs to be.
Right. So I think currently a run on Are We Compressed Yet on our set of 19 videos takes about 20 minutes, and John Mark yells at me if it takes longer than that. So that gives you some idea of our ability to do rapid turnaround there, which has been extremely helpful for doing development, right? Yes. So DALA is real time for low-res clips. And we have the ability to turn some knobs to make it even faster than it currently is. We just don't have a good, command line interface to access those things. But so we've actually streamed it, over WebRTC and Firefox, thanks to actually some patches from Ecker. And not at a very high resolution, but we have done it. And so, yes, this ability to do this kind of rapid turnaround without having to jump through the kind of hoops you have to jump through to work on HM, right, where you're getting your results on maybe one video or one or two videos and then hoping they generalize to the rest of the set, or scheduling things on batches to get you the results you want as soon as possible and all that stuff. Like having something that runs quickly makes things much easier. So.
Yes, I'm not going to further comment on that. No, but since the issue was brought up, Frank Boston again, since the issue was brought up earlier about what bit rates you're actually looking at, what does the 0.1 bit per pixel correspond to? Now you're mentioning 6 megabits for 1080p. That sounds like old generation codec bit rates.
Right.
That's probably not where you want to be, right? You probably want to be at 2 or 3 megabits per second.
Right. So, well, yes. So a lot of this depends on content, right? And particularly, yes, for sort of an average scene, yeah, you would want to be at much lower than that, right? But that yeah. So the bit rate on there is a log scale, and sort of basically like the high quality YouTube to low quality video conference is kind of bounding what we consider to be the useful range, if that makes sense.
Right, but as I said, to me these sounds like old generation bit rates, not where you want to be with the next generation codec.
We were sort of setting 6 megabits a second as like the upper bound of what we consider useful.
Okay, because I'm just sort of looking beyond and say you want to do 4K 60. That translates to over 50 megabits per second.
Right.
Which is pretty high.
Yeah, though we don't have any actual 4K videos in this test set.
But you mentioned you had Park Choice.
We do have Park Joy, but we're running it at 1080p in here.
Okay.
Yeah. All right. Any other questions? All right, thank you.
Actually, I think Joe has you're Jabber scribing, right? I think there's a question in the Jabber room that's been.
So Ross Finlayson says, have all the people who have contributed to the DALA software implementation via GitHub signed the equivalent of a note well?
No, they have not.
Is that something that you could get them to do, or is it too late?
Well, we could certainly ask, right? I mean, so not all of these contributions have been in the, in doing things like core algorithms. So some of them have just been like working on build scripts and things like that. And if people really want note wells for that, well, we can try to follow up, but... Yeah, I mean, we know who contributed what, right?
They have contributed what, and it's not clear to me that that actually would be necessary for any of the purposes we're discussing here. So, I mean, if someone's making an argument that it is, I'd be interested in what that argument is.
I'm just relaying for...
Yeah.
Also, sorry, John Magavana, just pointing out that most of the core algorithms that are right now have been written by Mozilla employees, and Mozilla has filed IPR statements. So.
All right. Thank you.
All right. So now we're on to the proposed charter text for a potential working group here. Go ahead and hit the next slide. You'll see it fits on one slide. So this is good.
So how many of you agree with this, please?
Okay, so we're not going to do this plenary style. We'll go ahead and... I like that. Yes. So we'll break this down into more manageable chunks. Keith.
Oh, are you going to present that?
Oh, I see. So it was not about the previous slide. That's good.
Well, I didn't read the previous slide. I have actually blown it up wide enough to make sure I caught it all.
You can print it out for a handy pocket guide. That's why it's in the proceedings. So the idea here is to charter a working group to produce a video codec that is competitive with current video codecs in widespread use, optimized for use in interactive web applications, and viewed as having IPR licensing terms that allow it to be widely implemented and deployed.
So, Keith Drage, it did occur to me that it's not actually very clear here whether we're talking about real-time or the YouTube-type applications or both.
The second bullet there says interactive.
Both of those with this codec, is that correct?
Certainly, I think the focus here is optimizing it for the interactive case. If it works for other cases, and I think there's some suspicion that it will, that's great. But yes, this is being optimized for the interactive case.
Yeah, so we are expecting a real-time usage.
Correct.
Yeah, just not coming over very well in the
I think it's the second bullet there.
So interactive in real time, so you may want to add.
So Ted was saying interactive in real time might not be the same in all uses. Noted. We can float that.
I was thinking, okay. So actually, let's go on to the second objective slide. I thought there was more text that covered that a little more squarely. Now, I guess I can just read this out loud. We have plenty of time. To elaborate, the video codec will need to be commercially interesting to implement by being competitive with the video codecs in widespread use at the time it is finalized. The video codec will need to be optimized for the real-world conditions of the public best effort internet. It should include, but may not be limited to, the ability to support fast and flexible congestion control and rate adaptation, the ability to quickly join broadcast streams, and the ability to be optimized for captures of content typically shared in interactive communications. The objective is to produce a video codec that can be implemented, distributed, and deployed by open source and closed source software, as well as implemented in specialized hardware. The working group will prefer algorithms or tools where there are verifiable reasons to believe they are royalty-free over algorithms or tools where there is royalty-free uncertainty or known active IPR claims with royalty liability potential. The codec specification will document why it believes each part is likely to be royalty-free, which will help adoption of the codec. This can include references to old prior art and or patent research information. I'm seeing
Everyone
no one
agrees
in line.
with that.
Okay.
Everyone thinks that's perfect.
All right. So, process. The core technical considerations for such a codec include, but are not necessarily limited to, the following. 1. High compression efficiency that is competitive with existing popular video codecs. 2. Reasonable computational complexity that permits real-time operation on existing popular hardware and efficient implementation in new hardware designs. 3. Use in interactive applications such as point-to-point video calls, multi-point video conferencing, telepresence, teleoperation, and in-room video chat. So that was actually the thing that I was remembering was further on in the charter that I thought addressed your point, Keith. Is that good, or do you want to see something a little more, I don't know.
Keith Drage, where here?
So bullet 3, which is at the bottom of the first column and top of the second.
Yeah, I mean, I don't know where it mind where it appears, but I think it might be useful to actually see the words real time or something like that somewhere in the charter. Yeah. Listen to, is it?
Yeah.
Okay. Yeah.
Okay.
But what I was stepping up to the mic to say was this is where I would also expect to see my comment I made earlier about, transcoding and maybe some words to cover that. I don't want to wordsmith that here, but...
Okay, but you feel that that's something that should be charter text as opposed to something that goes into requirements?
Well, I think it's actually probably in the it's arguable, but I think I would prefer to see it in the charter.
Okay. Can I ask you to send something to the list on that topic so we can have some wordsmithing on it?
Well, I'm not actually on the list at the moment, so but
can I ask you to join the list?
Yes, but
Bernard about Mike said it would be good to have. The way I read these things is, as good as, but it might be nice to have points of superiority where you feel you actually want to be better than, and that might be things like the automated configuration or built-in error correction or something where you're actually better than what's out there currently.
But I think it would be nice, but if it was good enough and people felt that the IPR situation surrounding it was okay, I think that would be a win, though, wouldn't you think? Or do you think it really has to be better?
Yeah, I actually think it does, because if you kind of look at, you're displacing something, and if you look at the history of when people are successful in doing that, there's something that they're able to say, in this scenario or this, we're way better, and it's not just like 10%, it's like 100%. There's something, if you look at Opus, right, it's not just a little better than G711 or G729, it's like a quantum leap better. And it's not just the IPR thing that's...
But that part doesn't hurt, right?
No, it doesn't hurt. I'm
Okay.
just saying you don't want to do all this effort and then say, well, we're freer than the other free stuff, right? That's just not compelling. It has to. I'm just saying the real bar in the real world is pretty high, so you might as well shoot for something that you think will actually cause this to be deployed. Because if that's not what your goal is, then it's kind of pointless.
And to kind of repeat Adam's question for Keith, you think that should be charter text, or is that a requirement in a document?
Well, you've got language. You don't have to say, set a bar, but
okay.
There'd be something like an auto configuration that gives you in-band FEC or something that's better than what's out there. You get to choose, but like they're doing the RTP at the same time. That could be a source of significant advantage over anything that's out there. So just something to think about.
So what I'm hearing is mostly it's like you're talking about competitive with. You'd like to see something a little more aspirational, like better than, or
it doesn't have to be. No, some areas you can say we just want to be competitive with, and that's all right. If you also are in some area that you get to choose if you're better than, so you say we're as good as the other guys on this other stuff, but here we're really shine and we're way better. That could just think of it as a salesperson how you would sell this. You want something not just freer than the other guy. It's actually better.
Greg Maxwell. We do want to be careful not to be the NetVC marketing working group. But I've always captured being better than in some dimensions as an element of competitive with. One thing we need to be real careful of here is that you can go down an endless rat hole in determining what metrics you use for defining better. And I know in the codec working group for Opus, there was a lot of time wasted and debate related to we wanted to be superior to something, and then that was a whole opportunity for people to rat hole about what the definition of superior actually is. And I think we found that using more general statements like competitive with was easier to get consensus around, where it's hard to say, should we use this metric or that metric? Is it really superior or not? We don't know. But is it competitive? Yeah, I guess it's competitive. So I do think that in the charter we should try to be very, even if we revise the text to include some of these considerations like being better in some ways, we should still try to be very generic in how we address this, because that helps consensus.
Harald Alvestran, speaking for myself. Just want to say that I completely disagree with Bernard on this point. The reasons being that one is that if we start saying things like must be better than existing popular video codecs, and our goal is to arrive at something 2 years out, well, you're setting up yourself up as a target. And the other thing is that I don't see the success of Opus the same way Bernard does, because It is not a quantum leap over AMRWB. It's just a little bit better. It's the fact that it's a little bit better than the other undeployed alternative that was critical in this point. So I like the charter text as it currently is on that point.
Richard Barnes. So on this topic of as good or better, I think that this is not really germane to the charter discussion we're having here, because it's not like that we will have as a process, an acceptance criterion for the ultimate spec. We won't say that the working group hasn't met its charter milestone because it's not better than something else. It's the consensus of this working group that it's done that matters. So I'm going to say let's put that discussion to rest in terms of the charter discussion, please.
Yeah, I mean that the ISG would be evaluating that. I guess would be that's the problem with that.
Bernardo, to clarify, I wasn't suggesting better on certain metrics. I've stake out certain areas, things that you want to do that haven't been done. Like in-band FEC would be something that hasn't been done, or ability to configure with minimal parameters, or so that it's not an argument about graphs. It's just something distinct that you have that other people don't have. And with respect to the AMR wideband thing, that was only in a narrow portion of the graph, right? Opus was way better across a whole range of things. So that's kind of another way to look at it.
So Keith Drage, tying in generally to what Bernard is saying, I mean, the Charter should represent what we're trying to do better than other codecs. And if the only conclusion we end up at the end of it, that it's basically to develop a royalty-free codec, I think we've failed. Because I don't even think we can guarantee it is a royalty-free codec based on the current procedures we have in IETF. So as far as I'm concerned, what we need to be addressing is we want to go out and develop a better codec than is currently on the market.
Sure,
and the royalty-free is just an incidental bit of it.
Right, the precise text on what RF is there in the lower right, right, and it's not that it has to be RF.
I mean, my problems start when you start on the very first slide of the Charter, where you actually have the royalty-free.
This one? Sorry.
What? Yeah, number 3 there. I wouldn't even have number 3 on that slide at all. I'd wait until later on in the Charter to actually say something like that, which you do anyway, I think.
Yeah, I don't want to too much wordsmith the Charter. I think that the spirit that is expressed in this, though, is the right spirit.
We should be trying to say in the Charter, we are going to develop a better codec. How you get that into words is up to you, but it shouldn't really be primarily just to be royalty-free. And that's what is coming across to me at the moment with the Charter.
Again, that there are 5 bullets up here, and we're talking about a variety of different qualities of this, suggests to me otherwise, but... Yes.
Steve Botsko. You might consider the word low latency somewhere. That might help solve this, what exactly it's for. But I think what I really want to say is I think it would be valuable to stake out a territory here. I don't think you need to say better than or whatever, but if there was something like built-in FEC or the configuration or something like that, it would be good to spell it out here, because I think it will be important to focus the group on doing something that does claim some new ground. And it's independent of whether you think it's better or worse or graph arguing is a waste of time. Right? So.
But again, is that something for the Charter to say? It's going to be FEC is the way this is going to be better? I think the Charter can say something general about this, but then there's going to be the work that's going to either do cool things or not, right? I mean, we always kind of take this risk when we charter an IETF working group that we were going to have some aspirations and either the technical work is going to bear it out or not. I don't think we need to agonize in the Charter over exactly what that needs to be.
Well, you already have a ton of text that talks about what it is, right? So you could take all this text out and make that claim, but given the amount of text you're already spending on how it compares to everything else, I don't think you really have a good case, right? I think it would be good to add like one more bullet item here that says something new you're going to do.
Gaël Martin-Cochet, I have quite a few questions. So if it has to be competitive with deploy codec at the time it's finishing, it makes it very vague. So maybe we need to have a comparison to something that is real. whether you want to compare to VP9, whether you want to compare to H.265, to VPA, to H.264. But keeping saying, well, it has to be competitive with whatever will exist at this point in time makes it a never-ending process. So that doesn't help with the work. So that's the first comment I have. Second, if you're aiming at something that is different and that is royalty-free, have you considered doing a core profile, let's say, that will meet those two requirements, even if they are less efficient than existing codec, and allow for a non-IPR-free profile on top of it? That may gather a bigger community around that codec. The question is, I think the comparison with Opus is historical. And Penn ITU have been trying to do royalty-free codec for a while now. They are looking at their next generation codec. If the IETF was to come in those groups saying, well, would you consider a core profile that will be royalty-free and then build upon different profile, would that be a solution to gather a bigger community, have more people involved in this codec, and basically respond to more needs than just the internet aspect that you're talking about here?
Hi. Eric Wishwala. That last bullet, the last parentheses needs to be moved before the word without. I just thought that would be helpful. I guess I had two small points. Point number two, it'd be nice to have some recognition of the diversity of hardware capabilities, namely, it says, existing popular hardware, right? And if we mean it should be implementable in software on a mobile phone, we should probably say so. So that would probably be useful one way or the other. With regard to the point Gail was making about core versus profile, certainly, at least from my perspective, it would be acceptable at the end of the day if we had a really pretty good core and then an even better profile that maybe didn't have quite as good IPR properties. But my goal would be to have a completely royalty-free core as possible, and that has to be a pretty good codec right there. If there were like a pretty good codec and then an even more excellent codec, I could live with that. But if we have a pretty good codec that's just sort of a core codec that's IPR free, it's just sort of that doesn't really work for me.
So to clarify your point on the mobile devices, this is basically you want some wordsmithing on point 2 here, where it says in addition to popular hardware, including mobile devices.
That would be satisfactory, or if we don't think that's a goal, we should not say that. But I guess all I'm trying to say is is this just desktop? Is the assumption it's just desktop computers, and that if you're going to do mobile, it's going to be hardware, or is the assumption it's going to be working software across a range? And if that's true, we should say so.
Thomas Edwards with Fox. My day-to-day job is dealing with video compression codec testing. So I'll say, first of all, I think it might be worthwhile for this group to do a gap analysis against existing codecs and existing profiles to see whether there are existing codecs which match the requirements that you folks are looking for. The second is that you can also take a look at specific, I think some folks were mentioning this, specific profiles. The Video Services Forum, for instance, right now is engaged in a project to develop a profile for JPEG 2000 for low latency codec applications under a frame, for instance. So they're starting with the JPEG 2000 codec, but defining a profile of JPEG 2000 which can provide this low latency capability. I think the other problem that you're going to run into is that the encode quality depends on the artwork of the people who are producing the encoding system. Even with MPEG-2, even with a very ancient codec, we're seeing continuous improvements in the performance of them year after year as folks learn how to use the tools in the compression toolbox and apply them better. And again, this is something one company will be better than another one, then another company will be better than another one, and the bit rate goes down and down. So the first pass through when you develop the codec system, your performance is not going to be as high as possibly several years down the road when you've had a long-term experience with this. And also I have to point out, what we're seeing with HEVC today, H.265, is that it is clear that it's not appropriate for software implementation for all resolutions and all frame rates. When HEVC first came out, it was only really capable of being done in software for small SD and sub-HD resolutions and frame rates. It's only now that we're getting to the point where we can even conceive of having HD resolution HEVC encoding and software. So a lot of this has to do with where you end up on the curve of Moore's law as well.
Tim Terry from Mozilla. I certainly agree that Moore's law plays an important point in the complexity of the codec. I just wanted to respond to Gail a bit. We've tried the approach of having a codec that was pretty okay, but also royalty free, versus something versus competitors that were better, right? So I'll use the example of Theora, which I worked on. It was not as successful as we might like. We also tried other people have tried the approach of we will have a royalty-free core and then build patented stuff on top of that, and that was actually H.264 baseline, and I'm still waiting for that to actually be royalty-free. The intention was always to make it that way. I'll let you respond.
Well, I think there is a difference between bringing some. MPEG and ITU are starting to think of their next generation codec. So having IETF liaising to them as an input saying, well, we will really want a core profile that is royalty free. Can the community, the overall community, not only the IETF, but the MPEG ITU community agree to that and commit to that? I think if that happens, that will be very good. Not trying is, in my opinion, quite wrong. Right? I'm not saying IETF should not be doing the work, but maybe IETF should try to contact those people and offer this proposal. Right? So H.264, we try multiple times to get it royalty free. I don't think we need to look back at the past, right? We need to move forward. Some more questions.
Before let's stay on that point for just a second. I mean, participation at the IETF has always been kind of self-selecting. People come to us because they like this venue, they feel like they're reaching a particular audience here, and we make decisions about what work we take on based on whether or not we assess we've got enough interest and contribution and so on from the people who are willing to put their butts in these seats right here. Right. And so, I mean, I think very similar arguments were made about Opus when we were talking about that back in the day. Is this the right venue for this? Isn't there more work that's been done on this in the ITU or wherever? And the answer is some people felt like there was a community of interest that was willing to drive something here, that the expertise existed. There were skeptics, though. There were a lot of people who got up to mics, right, at Opus and said, nah, this isn't going to work. The expertise isn't here, or other things have been done in other forums that have studied this vastly more than you can. But, I mean, I think it turned out our process was okay. And, it was a risk then, and it's a risk now. And the worst thing that could happen out of this, if we do it, is that we have an RFC and it doesn't light the world on fire. Oh, well. That's happened before.
I don't deny that. I don't think that's the point I'm trying to make.
Okay.
Okay. So let me try again. I lost my thought. So if you want something royalty-free in video codec, we know it's a much more coded field than audio as well, right? In particular, it seems you're targeting both encoder and decoder with the same IPR policy, which is everything royalty-free. I'm telling you, in MPEG ITU, there is a much larger community than here in terms of corporations. Those corporations that are not here will not have anything to declare into the IETF. So if you want to mitigate the risk of IPR, you may want to try at least once to liaise with those people. If they say they're interested and will consider it, then you may have a better chance to gather more people around a royalty-free initiative than just doing it in IETF with not informing those people of this activity.
So you just a few minutes ago made a point that there has been discussion in the ITU and other groups about producing a royalty-free codec. How long has that been going on?
I think it started with this WebRTC debate around H.264 and
so about 5 years or so, yeah.
1990, yes.
So I think
but I think it has changed as well. I think people realize that there is a move toward royalty-free. I think no one is denying that.
Right, but I think
either,
it's
right. So I think as part of the charter, there is a liaison process to ITU, MPEG, and all of that. I think that's on your last slide. setting up the group without contacting those people seems a bit premature. But anyway, two more questions. Is the encoder standardization effort that you intend to do will have the same royalty-free constraints, or is that applicable only to the decoder? And second, I think Mo said something quite interesting and say, we need to consider IPR risks that are unacceptable. Does it mean that there are IPR risks that are acceptable? And how do you make the difference?
So to that point, because it's an IETF process point, it's very much up to the conscience of the participants in the group to make that assessment in their own companies, and then we hum and decide what people think, right? And you know what? If, again, like I said, it's always a risk. Our IPR policy has been tooled through a variety of historical circumstances too strange to get into today, but thus far it is not done too poorly by us, and we feel, I mean, there are people here willing to argue anyway that it's worth trying it and see what we get.
Ted Hardy, Google, but actually with a point on how we evaluate the charter. I noted during Gail's talk that actually you have a whole collaboration slide to come, and that it might be useful for us to go all the way through from here and then come back to this point, because I think some of the issues that are being raised are actually dealt with more substantively later in the slides or charter, and we therefore might make a little more focused progress.
Thank you.
Melzanetti, quickly, because I know it's what I'm going to mention, not addressed in the later slides. Gail's comment sparked the thought about, are there IPR that the risk is acceptable? I think there definitely is. That have to be a consensus of the working group to come to that opinion. But what may be useful, and maybe even it should be charter level, maybe a milestone or something, if someone would be willing to undertake the work of identifying IPR that we know can be used, things that may be expiring in the time frames that we think are useful, and that discuss tools that we think are very useful and relevant even in modern codecs. So a little bit of work like that may be useful for someone in the working group to try to undertake. Publishing a list of the known IPR that will expire relatively soon or has already expired, that could be useful for this work even in modern codecs.
And why don't we table the rest of that kind of collaboration or what we can do outside of the context of an IETF working group until we get to the collaboration slide, which is like 3 slides up, as Ted suggested.
So
this is not on that point, Jeff?
This is not on that point, and I'm channeling.
I understand.
So this is from Randall Jessup, going back to what the conversation before about what does better mean. I agree with Harald and others. Better is a rat hole to define, and not really the success criteria. Competitive, especially for interactive/RTP use, and RF as best as possible is what we should say if we need to say something about quality/performance. Targeting to be better for at least some use cases for some unspecified in the charter/requirements definition of better is still a goal. To the person from Fox, a large part of the impetus for this work was the IPR issues surrounding existing codecs, as shown by the hammer and tongs around selecting an MTI codec for WebRTC.
Not on the collaboration point this time?
No, great timing. Thomas Edwards, Fox. Regarding intellectual property, I've been involved in a couple of different standards development organizations. The best and only thing you can really do is you can ask for the participants in the room to say if they have any knowledge or personal knowledge of patents or other intellectual property to declare it at the time, which I believe the IETF does. There's not much else you can do. The problem is there always will be people not in the room. And actually within IETF, this is a bigger risk than it would be within JPEG, for instance, or MPEG or SMPTE. There are always going to be people outside of the room who may have intellectual property that you'll never know about until a codec becomes popular enough that there are deep pockets for the submarine patent trolls to come for you. This has already happened with MPEG too, so this is a reality. That you can only do the best you can, and unfortunately you've got to leave it to the business situation for the submarines to come to the surface if they're there. Notable exception of JPEG 2000, which I feel very solidly about regarding intellectual property. All their codecs, you never know. You just never know.
So this is true about every technology the IETF develops, and it was true in very similar ways for the Opus codec. So I think there's probably a pretty good understanding among the people in this room about what you're saying isn't wrong. It's just what we live with as a standards organization in every area and every effort that we work on.
And it's also, just to add to that, it's not merely the participants in this room who are all engineers and such. There are people here who work in companies, and those companies have lawyers, and they talk to those lawyers, and those people make an assessment. And that does end up factoring into what we do here. And I understand some of those lawyers at least look at broader spaces before they counsel us, if they're doing their jobs. Why don't we finish going through the charter text?
Okay. I'm happy to resume so yes, we're back to the technical considerations. We want the codec to be resilient in the real-world transport conditions of the internet, such as the flexibility to rapidly respond to changing bandwidth availability and loss rates. We want it to be integratable with common internet applications and web APIs, for example, the HTML5 video tag and WebRTC API, live streaming, adaptive streaming, and common media-related APIs, close parentheses, without depending on any particular API. And the working group shall heed the preference stated in BCB 79, which is that in general the IETF working groups prefer technologies with no known IPR claims, or for technologies with claims against them, an offer of royalty-free licensing. This preference cannot guarantee that the working group will produce an IPR unencumbered codec. Okay. We also have some explicit non-goals. We are not optimizing for very low bit rates, such as those below 256 kbps. It's out of scope because such work might necessitate specialized optimizations. Bernard.
Yeah, so I do have a comment on this. People mentioned mobile, and just to kind of give you a perspective on it, right, with mobile devices going to lower and lower price points, a very significant portion of all your users will be in that condition. Like if you look at the use of Opus today, particularly in the African continent, the lower portions, the bitrate portions, are used very, very extensively. So it's just something to think about. Again, one of the unique points is how do you get video to, the less developed world? And if you can operate in those bit rates, it will be a very significant advantage, particularly on the lower priced phones like the HTML phones or stuff like that. So you might, I'm not saying you should optimize and do everything, but if you can show that you have decent operation, it actually will be a pretty big deal.
Mosinee, I think we should just strike that. I don't see much use of having that, limiting the scope to specific bitrate ranges. I think this was historically there for Opus because some special techniques are typically done at very, very low rates for audio coding, but there's not really any special techniques that have been proven successful for video coding at very, very low rates. So I think this is really not very useful, and trying to limit the ranges of operation in the charter doesn't seem wise. That seems more requirement level or even evaluation methodology draft level text that should be added.
Yeah, Tim Terry from Mozilla. I have no problem with striking that from the charter.
Okay. Does anyone want to speak up in support of keeping this? Okay. That's good feedback. All right, so continuing with other non-goals, it's explicitly not a goal of the working group to produce a codec that will be mandated for implementation across the entire IETF or Internet community. Okay. Based on the working group's analysis of the design space, the working group might determine that it needs to produce a codec with multiple modes of operation. The working group may produce a codec that is highly configurable, operating in many different modes with the ability to smoothly be extended with new modes in the future. So basically, it's not a goal to have a single mode of operation. Okay? So collaboration, and this was a slide that we were talking about before. In completing its work, the working group will liaise with other relevant IETF working groups and SDOs, including Payload, RMCAT, RTC Web, MMusic, and other IETF working groups that make use of or handle negotiation of codecs, W3C working groups, including HTML, device APIs, and WebRTC, and ITUT, Study Group 16, and ISO IEC, JTC1, SC29, WG11. Oh, I thought that was a comment. All right. It's expected that an open source reference version of the codec will be developed in parallel with the working group. The working group will accept and consider its decision process input received from external parties concerning IPR risk associated with proposed algorithms. Joe.
So I know that we don't have a specific liaison to study group 16. Would you ask the IB to sort of get that going, or?
We don't have a liaison to study group 16?
Huh? We have a general liaison to ITUT.
Yeah.
But I mean, so I'm willing to take an action item, or for Ted to take an action item for us to explore that on your behalf, if you decide that you think you're going down that direction.
Okay.
But
So
I'd just like to give a heads up to the program for them to start thinking about that,
right.
if you think that's a useful thing.
Thanks. We'll talk offline.
Fair enough. I just wanted to sort of put that in your list of things to think about.
Thanks. Can we make sure that the notes capture that, Colin? Now that you're standing up and can type easily. All right. Thanks.
Yes, thank you. Hello, this is Georg Meyer. I'm, besides other things, the 3GPP IETF liaison, the new one. And I think it would be good to add 3GPP SA4 here, because they are also working on codecs and get involved in that work. Thank you.
Thank you.
I promised to myself not to go to the mic. I do it anyway. Stefan Wenger. I'm currently the IETF liaison to MPEG. And the technical work, the majority of the technical work that's going on with respect to video coding is in these joint committees between MPEG and the ITU. My personal estimation is that's not going to change when they start with H266. So if you want someone competent and not only the brass, just go to them. I go there anyway, I will do it, so I'm not sure that we have to over-engineer the specific ITUT study group 16 liaison exercise. Thank you.
Thanks. Okay.
Colin Jennings, I'm fully confident that Stephen Winger can deal with whatever information getting there. I don't think we need any special liaisons with ITU. All the information will flow in just a fine way. We way over-engineered that on the Opus charter. We went way overboard on it for various reasons, and I don't think it's really a concern. The people in the widespread video community are well aware of this work. If it moves forward, they'll be aware of it. There'll be people who move the information back and forth. Nothing special is needed.
Okay. I think we finished this one, right? Yeah. Okay, so our list of deliverables. First, we're going to produce a document that outlines the IPR terms the working group wishes contributors these specifications would use to license their IPR. Bernard, is this on that point?
No.
Okay. Do you want me to wait? Do you want to wait till the end of the slide? Or do you want to speak now?
Yeah, I can wait till the end.
Okay.
I can wait to the end of the slide, too.
Okay.
It is on this one.
Second, we want a set of technical requirements and evaluation metrics. The working group may choose to pursue publication of these in an RFC if it deems that to be beneficial, but this might just be an internet draft that informs the work and then dies. That last part, for anyone listening on the audio stream, was me parenthetically not actually in the charter. A proposed standard specification of an encoder and decoder where the normative algorithms are described in English text and not as code. Specification of a storage format for file transfer of the encoded video as an elementary stream compatible with existing popular container formats to support non-interactive, such as HTTP streaming, including live encoding and both progressive and large chunk downloads. The working group will not develop a new container format. And a collection of test results, either from tests conducted by the working group or made publicly available elsewhere, characterizing the performance of the codec. This document shall be informational.
So, Bernard above Mike. My comment is there's no RTP payload format. Why not do that here too?
That's generally in the charter of ABT Corps, my understanding. Is that? Sorry? Payload, sorry, yeah.
Okay. But there are advantages to doing it so you'll do it in payload at the same time.
Yeah.
Okay.
Right.
But that.
Ted Hardy, I believe your first document is a giant rat hole, mostly useless and completely avoidable. The rats in the rat hole, you know well enough. The mostly useless is because many companies which have IPR will not adjust their terms in order to meet whatever you've said. Instead, they will have their terms, and as is typical for the IETF, the risks associated with those terms then get evaluated here in the typical IETF way. So I think that you probably shouldn't start a working group down the path of doing this before, because this is now a gating item, before contributions to the other specifications. Start by immediately having something which is an attractive nuisance before you get any work done. So I would simply say, elide that document completely from your set of deliverables to avoid the rats in that hole.
Mosinati, quickly on the IPR that Ted mentioned, I think it'd be very useful to have something, not about the terms that we want people to use, but like an IPR survey or something that we can continually, add on to. Like I mentioned before, something about the relevant IPR that may be expiring or is expired would be useful. I think some kind of deliverable like that would. I think not on 1, 2, 3, 4, 5 deliverables, but is this trying to list all the milestones?
So I guess the interesting thing about making that a deliverable, right? Like it's going to be a document that's going to live here. I mean, is it going to be the subject of IETF consensus in some sense, right? I mean, if we don't eventually think we're going to have everyone in the group agree or not with what's in the document, it might not be an IETF document. It sounds like a useful document,
Okay.
but I think that might be a useful living document that we'll just put up in Git or something, right? And like.
Yeah, I think when we talk about, this is Richard Barnes, I think when we talk about deliverables, what we have in mind is the documents that the working group will be sending to the IESG for approval.
Right. But yeah, I think it's a good idea.
And then two minor nits, but probably important ones. Second bullet, evaluation metrics. I think that should be evaluation criteria, because I think there'll be more than metrics there. There'll be methodology. There'll be, configuration, things like that. And then number 3. I'm surprised nobody's mentioned the, encoder versus decoder specification. But it may be a way to skirt around that is to say, rather than encoder and decoder, of an encoded bit stream and decoder operation. I think that's more in line with what codec specs usually do. So you don't say the encoder must do this. You just say that the encoded bit stream must conform to this, and decoder operation must conform to this. So that's what we typically specify.
Thanks. I think the point of the bullet was more along the lines of we're going to do it as prose as opposed to code, but that's a very good point to make. Thanks.
Frank Boston. Actually, my point was exactly on item 3 in the encoder. Basically, the way it reads right now is you want to define normatively what the encoder should do, which, is okay to do. I'm just trying to understand whether that's really the intent here. Whether for the encoder you just want to give an informative example of how you might encode something, or whether you want to make any of it normative. I think that should be clarified.
Right. No, I think that's very much in line with what Mo was saying. Is we want to talk about what the encoded bit stream looks like as opposed to the behaviors required to produce it.
Cullen Jennings. I want to go back to the point Ted made about this point 1 on this. This is one that I've worked on a lot. Our previous experience was there was a lot of people using the Opus license, for example, or using a piece of technology, wish there was one license that they could easily evaluate to understand all the IPR around it. I mean, the more things that they had to read, the more work it was for lawyers to do it. So there was a definite feeling that it would be nicer to have, the smallest set of different IPR licensing terms towards the piece of technology possible. Now, when we got to a very late stage, it was very difficult to get agreement on that because people were already committed and everything was into the standard. Where we felt that it would have been very easy at an early stage to get everyone to agree to that, but by the time it was all done, it was very hard to get people to change from where they were. So Opus ended up with a pretty diverse set of things on that we're trying to get around. Now you could go, okay, so that has nothing to do with the IETF. Still a bunch of people, it's going to be in the end, some lawyers from some various companies are going to try and figure out what set of terms they're going to put there. The problem that's come up, and this was very specific from Cisco Legal, is the companies that are large and have anti-competitive concerns in this space, their lawyers are very dicey about them constructing the terms of this type of stuff. In the same way that they wouldn't want to just create a standard and put that on, force that out on the world in a proprietary sort of way. So there's a real desire to have a consensus effort in a forum where you can have those types of discussions and not have anti-competitive concerns to develop the text that many of the large companies would use to put the stuff into here. And there's already been some progress on that. But that's what drove it, was a desire to be able to develop one common set of text instead of a bunch of different types of text, and a desire to do that in a way that didn't raise anti-competitive issues for large companies. Thank you.
So Keith Drage, I mean, I would actually support Ted in his proposal that we actually do not put this as item 1 and reword it as something later in the process. I mean, as far as I'm concerned, the IETF has an IPR policy, a set of RFCs we need to follow. Those are what should apply, and I do not think this working group should set up its own set of IPR rules that are distinct from the normal IETF ones. Thank you.
Just a second. We've got to address this. Keith, this is not discussing anything remotely like that. We need to explain what this...
to be doing that. That's the point.
Okay, then this... how could it... the IPR terms the working group wishes contributors to specify they would use to license their IPR. How could that be read to... Okay. Okay. It's a desire.
I mean, would it be clear to phrase something more along the lines of suggested terms under which companies may contribute their IPR, or something along those lines? Because I think that's keeping in the spirit.
But we do already basically have that. Again, the RFCs we already pointed to contain language very similar to that. So if it's going to be different in this, right, then we are going to be differing from the... So in that sense, what Keith is saying is trivially true, right? I mean, but that's an important question. Do we want the terms to be different from what our standard, the standard IPR terms are in the BCPs?
Yeah. Greg Maxwell.
I'd be interested to hear from people who feel that.
There's a difference between a requirement and a shilling point, right? I think that there are many parties that will go along with recommended terms, even some surprising ones, and we'd like to have as many parties as possible on the same set of terms, and the working group can potentially provide a collection point to get people onto that. But we're not saying that the charter isn't saying that it would fail if the whole codec weren't available under a single set of terms. And I think that's what distinguishes it from BCP, because the BCP stuff is mandatory.
No, not at all. It says that it's up to the working group to make its assessment.
Right, but it is mandatory that it is up to the working group. The BCP is setting the requirements for how the IETF works. And this is just we're saying what our preference is.
I suggest reading the BCP and seeing if it's really any different from what you're saying.
But I think it is, and I've read it.
Okay.
Ted Hardy again. So I understand Cullen's point about doing this early then allows you to avoid the problem that people who've already made contributions then must determine whether or not that contribution kind of backfills into the license which is there. But I point out to you that if you try and do this in advance, what that's going to actually do is, one, you're going to have all of this argument about what the appropriate licensing terms are when people don't know what they're contributing yet. And that in and of itself may be a problem. So I think you're going to have a problem dealing with this in any way that you're just picking where you do your poison, and if you take the poison at the beginning of the working group, there's some known issues with that. The other point I wanted to make here that kind of goes back to the point that John was making and that I think Keith is alluding to is, if what you want to do is to say, here are a set of known licenses whose contributions we believe meet the working group requirement, you can point to the ones in the BCP and then ask yourself, are there other common licenses that have arrived on the scene after that was written, for example, that it would be useful to include so that you can tell contributors, hey, if you use one of these licenses, the working group will already know what its assessment is, right? That doesn't try and tell anybody who's got license terms set by a corporate lawyer or by some other mechanism that those won't be accepted. So it's not a preference in that sense. It's simply a statement that says, hey, if you're using one of these, we already know what the outcome of our assessment will be. And that might be useful, and it's not gating because you could update that set, increase it over time.
And we're probably going to have to cut the mic here, just given where we are. But there's there's a lot to be said with what we've got. So,
Yeah. So, Ted, I think that is very much in the spirit of what was intended here, and I would encourage you to send text to the list that makes this look more like what you just said. I would also point out that we actually have a set of terms, the ones that Mozilla used on their declarations, that we believe would meet this, and have been asking for feedback for, 2 years on those terms and haven't gotten much. And maybe that's because people don't know what they would be contributing yet, and so they're not going to give feedback. And maybe it really is impossible to do this at the beginning. I don't know, but I'm not seeing a huge rat's nest build up over that. Like maybe it will as this progresses further. So I don't know.
Stefan Wenger, wearing only my own hat. I've worked on patent policy work for about a decade now. I have some familiarness with this type of stuff. If an antitrust lawyer here were in the room, he would have run out by now. And I was really about to do the same thing. I cannot recommend to have this form of discussion. I cannot recommend to you to come up with a positive list of terms. I cannot recommend to you to come up with a negative list. That's probably worse than a positive list of terms. I would also mention that it is pretty clear that when you say you have a goal of royalty-free, right, that people can dream up something which specifies exactly how far they are willing to go with giving up rights they may have, and not further. And clearly, my feeling is that the majority of the people here are probably not qualified to deal with this type of discussion. So again, my recommendation is to stop this this effort for the text that's being written under IETF auspices. What I would say, though, is that it is, in my opinion, completely legitimate to do something like this for this open source code base. So if you want to have a CLA there and something like that, go ahead, be my guest, and people will then decide whether they can accept that and contribute to it or not. But don't go into that with respect to the standards text. Thank you.
Harald Alvestrom, just about BCPs. BCP 79 does not contain licensing terms.
Right.
If anyone knows of any BCP that contains licensing terms, I'm certain there will be. That's why I said licensing terms. That's what it does not contain, and the IETF lawyer will be happy to advise you on why it does not.
Yeah.
And I think the discussion has provided enough ammunition to strike the first bullet. I think that's the simplest solution. It would also be possible to reformulate it as outlines the requirements of IPR terms, but that's a rat hole.
All right, Eric Criscorla. So I guess I don't feel strongly about this one way or the other, to be honest. I do recognize Greg's point about having a shilling anchor point, and I agree that would be of some value. But I also think Ted's point about not having this be a blocker for all work is obviously is critically important. So allow me to suggest a number of possible alternatives that might soften this a little bit. Yeah, so one would be to simply move this down and simply say, like, this is item number 4 instead of item number 1. I don't really see it has to be a gating factor on contributions. I certainly hope not, because people have already amended much of the stuff they will be contributing. Another possibility would be to rephrase this as example terms, or and have more, and potentially have more than one set. The other thing I would observe, frankly, is that if Opus is any guide, the ultimate codec we develop will be largely consisting of contributions from 1 or 2 organizations within, and that'll be then incrementally improved. And so if those people come in, whatever we eventually choose to accept, I would imagine that we can treat the terms that they input their IPR as sort of the anchor licensing terms. So I'm not, even if we don't ever have a group consensus, I mean, it seems like if we get that out of the way early, then that could serve as an anchor for new contributions, even if we never have a group ratification or something.
Colin Chus, I want to say, I was one of the proponents of this point in many of the discussions leading up to this charter, but if this is stopping us between getting done, I'd rather just see it removed. This is a low order bit in figuring out what we need in this charter. This doesn't matter if it's there or not.
Is there anyone here who really feels strongly we should keep this in? Okay, thank you. Let the records reflect no one felt strongly.
Okay. The milestones, I'm not sure this is all that useful to go over, as it is merely a mirror of the previous slide. The only thing that's new information here is the intended designation of informational versus standards track. Obviously, if we strike the IPR deliverable, we strike the IPR milestone, and we would have the requirements be informational, the codec specification, the storage format be standards track, and the testing document be informational. Okay. So do you want to run this, or do you want me to do it? Okay. So,
go ahead.
Frank Boston, question number 3. It says date TBD.
Come on.
Now, I understand you may not be able to set them by a month, but what are we talking about here? 1 year, 2 year, 5 years, 10 years?
I'm looking to Tim. He's closer to the technical aspects of this.
Right. So, in terms of freezing the bitstream, we have talked before about finishing by the end of the year. That may not be technically feasible depending on what kind of input we get from other parties. And so, so that really depends, right? It also, if we work on this for a year and we find out that we're not where we need to be, we might go on longer than that. So I think a year is probably optimistic at this point, given where we are already in the year. But that's sort of a vague guideline of where I expect this to be.
If I can plumb that real quick, how long did Opus take?
Opus took 3 years from the point of charter.
Okay, and do you think this is based on the work that's already been done? You think that this is a smaller chunk of work, or about the same?
This is probably a larger chunk of work. I think we have more people working on the core algorithms than we did for Opus.
Okay.
Gail Martin Cochet. So are we assuming it's DALA the baseline, and that's why we can give a timeline, and it has to fit in the DALA framework?
We would definitely take anyone who showed up with a proposal and invite them to work on coming up with a bitstream and a decoder.
So Keith Drage, just a minor comment on the milestones. Can you just take a pass through and make sure they do align with the steps earlier? So for example, the one I noted is that a testing document implies something different to the collection of test results that is shown in the previous slide.
I think it's just, rephrased to be really short.
Well, it's
test
been rephrased
document.
to imply something different. So all I'm saying is take a pass through and align.
Okay.
Send text. You can actually send that just to the chairs directly instead of the mailing list. Okay. So we're going to go ahead, and I would normally have our smiling area director stand up and smile as we do this. Is he? Right. Oh, there he is. Okay.
We got a couple.
All right. So we have a handful of questions that are generally at the end of a BOF to sort of it's to inform Richard in making a decision with the IESG about whether this is something we want to move forward with. So this is information for the IESG. We're going to ask in the room, and do you want to do hums or hands?
2 hums.
Let's do hums. Okay. So we're going to ask people whether they believe this is. Oh, that's right. Thank you. Whether this is a problem that needs to be solved. Do you have a question, or?
Are we talking about a technical problem? Because I know in other standards organizations, the problem they have to solve is to keep engineers busy.
Yeah, there's no risk of us
So
running
I don't
out of
want
work
to
to do with the
misread the
IETF
question.
if that's what you're worried about.
So I think in terms of making the internet better, which is the mission of the IETF, is there a problem here? If we did this work here, would we be making the internet better in some way?
Okay, so I'm going to go ahead and ask for a hum. We want positive and negative on this? Yeah, we'll go ahead and do a positive and a negative on this.
An intervention.
Okay.
Yeah, Thomas Edwards, I think the problem is I don't see the problem up there. In other words, is there a problem that needs to be solved? Specifically, what is this problem? Because now it's unclear that we're talking anything about IPR or royalties. Now it's unclear exactly what technical requirements we're trying to hit. That's my problem in answering.
So, we can go back to the goals slide if you would care.
Well,
Yes.
It's still unclear to me personally.
Okay. You can abstain or hum no if you want to. So, all right, let's go ahead and take those who believe there is a problem solving, hum now. Okay. And those who believe there is not a problem worth solving in this space, hum now. We're going to call that strong and unanimous for the minutes. And I have quite a few in the Jabber room concurring with that. Okay. Second question. Is the scope of the problem well defined and understood? Is there agreement on what the working group would need to deliver, taking into account the conversations that we've already had in this room and the agreement that those imply? So, do we understand the question? All right. Those who believe that the scope of the problem is well defined and understood and that there is agreement on what we would deliver, hum now. Okay. Those who do not believe this is the case, hum now. Okay. So that is strongly biased towards the first with some dissent. Ben, do you have something to say?
No, I was just moving over because 10 hums really loud.
Okay, so
just a minute before you move, just for notes there, say again what you wanted recorded in the minutes of the consensus of that call again.
We're calling it in favor. There was a small amount of dissent, but from up here it was pretty minor. There was a strong support. Okay, and this one we're going to do a show of hands, just to get better quantity. So people willing to do the work. So who is willing to write the documents that we've defined in our charter? Okay, I've got a good 6 people at least, yeah? Anyone in the Jabber room? 7, okay. All right. The second question we're going to ask is who would be willing to review these drafts as they're produced? I'm not even going to bother counting that. That's at least a dozen. All right? And the third is who will implement, test, and characterize a reference implementation? Already did. Okay, and that's a pretty good chunk of people as well. And I will actually indicate for the purpose of the minutes that we also had the slide indicating 37 people who have already been working on this. Okay. And then the final question, we're going to do this as a hum as well. And if you hum in opposition to this, you are again invited to speak up at the microphone to inform the chairs specifically about your objection. But we are going to take first a positive hum. How many people, and by positive this would be thinking it should not be formed. Thank you. So, how many people think a working group should not be formed at the IETF? Hum now. Okay? I heard maybe 1, maybe 2. And how many people believe that we should form a working group at the IETF? Hum now. Okay, I'm going to call that the majority of the room, so strongly in favor of forming a working group. Okay, do you want to say anything, Richard, or are we pretty much concluded?
So, yeah, I think we're pretty much concluded. I think that the discussion here was helpful. We probably need to have another couple of round trips on the mailing list to refine the charter, but I think we're on a pretty clear path to take this to the IESG and to the IETF for last call.
Excellent, thank you. And before everyone leaves, can someone grab the blue sheets and hold them up so I know where to retrieve them from? Got one there, and both of them there. Excellent, thank you. All right, thank you very much. We appreciate your participating.